Consider the doubling sequence that starts with 1 and then doubles each time, so you get 1, 2, 4, 8, 16, 32, and so on. What happens if you add up all the numbers in that sequence? And what do you notice about your answer? Okay, so this is a little twist on the classic doubling game that every maths teacher loves to play with their pupils. And I even play it with my little 5-year-old. We start with the number 1 and see how far we can double. And I'm pretty sure it's written into the PGC somewhere that every maths teacher needs to be able to get to 5 digits without really thinking about it. So, I'm going to model this with Q's and R, and I'm going to build these numbers to begin with and show you what happens. So if we start with the number 1, just like that, and then we double that, we get 2. Now the rule is I'm going to double the length, then the width, then the length and the width, and so on. So I'm going to double the 2 and get 4. So I've doubled the width. And now I'm going to double the length to get 8. Now I'm going to double the width to get 16. And then finally I'll double the length again to get 32. And the question is, what happens if we sum these numbers? Okay, so hopefully you've had time to think about this and come up with a nice answer. Now, I'm going to demonstrate why it works by using this 8 by 8 square here. And I'm going to start off with this largest term here, this 6th term, which was 32. And you can see, if I place this into this square, I use up exactly half of the area that we've got. So that leaves me with 32 left to fill. Now I've gone to the next largest term, this 16. And if I place that, you can see the same thing's going to happen. I'm going to fill up exactly half of the remaining area. And I'm going to keep doing this, halving the areas until I've used up all the terms. Place the 4, leaves me with 4. Place the 2, leaves me with 2 left, until I get down to this 1 here. And when I place the 1, you can see almost rather annoyingly, I'm left with this 1 unit left over. But that does allow us to quickly calculate the sum of all these terms, because this was an 8 by 8 square, and 8 by 8, 8 squared is 64, but I've got 1 square left over, so I just need to subtract 1 from that, so the answer is 63. Now the question is, how might we generalise this then? Well, 64 is the 6th power of 2, so I could have written this as 2 to the 6 minus 1, which is obviously 63. And notice that there were 6 terms in the sequence, 1 plus 2 plus 4 plus 8 plus 16 plus 32. So we can generalise this for any length sequence, and the generalisation would obviously be 2 to the power n, where n is the length of the sequence, minus 1. So if you ever play the doubling game again, if you manage to get up to 1024, and your pupils might get stuck then, say, okay, can you add up all these terms from 124 all the way up to 1024? And all they'd have to do is double it, 2048, and then subtract 1 from their answer.